Hello, welcome to Einstein's Mechanics. Today we are going to start with centroids. This is our next episode, centroids. So here we are going to talk much about centroids, how to locate the center of plane figures, composite figures, and it will be interesting. Let's see how we can get the basis. So centroids of shapes. Let's first look at this. A body or structure consists of parts, each subjected to its own weight or force, the weight force. These forces are vertical and parallel to each other. So what we are trying to say here is when we consider any body, it has its own parts. For example, let's consider this plane figure. So let's assume it has another shape attached to it. This too, there's another shape attached to it here. Let's add another shape to it. Say there is a support here to that. So this is the body we are talking about, or the structure. And it consists of many parts. Yes, this is part 1, this is 2, this is part 3, and this is a part 4. And remember, each of the part has its own weight. If we are to detach part 1 from the main body, it is going to have its own weight. Please pay attention. This is the basis of getting centroids. It is going to have its own weight. If part 2 is detached from the body, it is going to have its own weight and what? Force. And what we are saying, these forces are either vertical or parallel to each other. Are we okay? Depending on how we will place the force, this weight, it is going to be either parallel or what? Vertical to the other components. So now that we have the idea of a body having many parts and each of them having its weight, then these forces may be replaced by a single vertical resultant of magnitude equal to the total weight of the body. This is very simple. From some idea of resolution of forces, we saw that if we have a system of forces, say this is the Y, this is the X, and we have a force F1, another force F2. Let's take a third force F3, each of them making an angle theta 1, this is theta 2, and we have the large angle as what? Theta 3 with the X. These forces can be replaced by a single force called the resultant. Are we okay? The resultant force, which is equal to summation of force on the X square plus summation of force on the Y square. We dealt with such instances. So if a body has this series of forces acting on it and can be resolved to a single force where the effect of this single force is equal to the effect of this three force to get the result. And the same thing when we come to centroids, what we are trying to say is we want to locate a place where this force is acting on this member 1 or member 4, the force acting on member 2, the force acting on member 1, and the force acting on the main, let's say, main member 3, can be replaced by a single force, let's say a point here, by a single force R, the resultant, to produce the same effect as the single forces acting on the bodies. Are we okay? So the force may be replaced, these forces may be replaced by a single vertical, it's supposed to be a single vertical resultant of magnitude equal to the total weight of the body and acting at the center of gravity of the body. Where we will place this single force producing the effect of these small forces of each of the parts is referred to as the center of gravity of the body, and that's where we call the center or the centroid. That's what we are trying to find in this course. We are trying to locate a place where we can place a single vertical force to produce the same effect as these small forces of the individual parts. That's what we mean by centroids of a shape. It's very simple. So now we have the idea from this. For example, the human body, let's assume this, has many parts. So for your legs, there will be some force acting, let's say F1. For this leg, there will be an F2. Your hands, F3. This two should be F4. Let's say a force acting, the head is what? F5. So here, what we are trying to say about centroids of a shape is we want a place within your body where we can place a single vertical force called the resultant that will produce the same effect as these 5 forces acting on the body. And now we are not interested in the magnitude of the force, but in these topics we are interested in the location where this force is supposed to be placed. In basic mechanics, we were interested in the magnitude of the force, but here in centroids, we want a place to place the vertical force, and that place is serving as the center of the body or the center of gravity of the body. Let's look at from this area. Looking at this shape, it is an irregular shape. Are we okay? And we are trying to locate the center. It is not easy to locate the center of an irregular shape. When it comes to centroids, there are major things that plays role for locating the center. But here it is an irregular shape. First, put it in mind that the center of any shape will be obtained from the what? The axis, the x-axis, and also the y-axis. So always there should be a reference axis for you to locate the center. Remember, there's always a reference axis that will help you locate your center. So looking at this shape, we are having a y-axis and an x, but from deduction we are seeing that the center or the center of gravity, the centroid of this shape, is located here. If you are to locate this, the center of this irregular shape by observation, maybe you say the center will be somewhere here, right? But that is wrong, because this is an irregular shape, so the center is not there. From calculations, it was seen that the center is here. Don't worry, what we'll be dealing with will be plain figures with symmetric shapes, or where we can use formulas to obtain the shape, but some can be obtained by observation. But here it is located here. This is where you can place a force, a single vertical force, to produce the same effect as the other forces. Are we okay? So this, we were trying to prove the center of shapes. So once it is an irregular shape, we take a small portion of it, then we apply our integration to the small part. So once we know the center of the small part taken, then remember your integration can integrate this small part into the whole plane figure, so that we can locate the center. And with that, it's easy to do. Don't worry about that, we will do much about it. So what I'm trying to say is always remember a reference axis, because you must start from a point and end at a point. So looking at this, to locate this center, you must move a certain distance x bar on the x-axis. So the distance you move on the x-axis to locate the x distance is called x bar, and you must also move a certain distance along the y-axis to get to the same point. Are we okay? And that distance is also called y bar. So this x bar, y bar represents the center of this plane figure. Sometimes either of them can be a zero distance depending, and we will see how we can go about it. And also remember, we can do or predict the center of a plane figure by observation. By simple observation, we can just predict the center because those shapes will be plane figures. Are we okay? Now, let's look at some simple shapes and their center, or how to locate their centroids. Always, I said there should be a reference axis. Pay attention to where the axis lies before you start your deduction for the centroid. Are we okay? Because the axis is not always going to be at the ends of the plane figure. Looking at this shape, it is at the ends. Y and X are at the ends of the figure. But it is not always. Sometimes the axis may be at the middle of the figure. How do you also obtain your centers? So in situations like this, where we place the axis at the starting point of the figure, this is a square, right? Because it has a height b and a base b, so equal size, and that is a square. By observation, if I ask you to locate the center of this square, definitely because the shapes or the size are equal, you can just place it at the middle to say this is the center, or where the center of gravity is. Are we okay? And how did you know? It's just on the x-axis. So to locate the center of a square on the x-axis, you are going to move half of the distance given. So that will be half of b. And on the y-axis, you also move half. This whole line, or this whole shape, is b. Let's say b. So half of here, this b, if you move half of it and you move half of this, you are going to meet at a point so that you get the center of this square, depending, because this axis is at the ends. Are you okay? So this is how to obtain the center of a square. Just move half of the base on the x, move half the distance on the y, and you are going to locate it. So assuming this is 10 meters, meaning the centroid of this square is going to be x bar, y bar is going to be 5,5. If you move 5 centimeters or meters, you are going to locate the center, depending on where the axis lies. I've been saying this for quite a long time, depending on where the axis lies. So this, we have a rectangle here, because the height is of different dimension to the base. This is b, they are not of equal size, this is equal to that. So this is a rectangle, and to locate the center of this rectangle by observation, again, it is very simple. You can just move half of the base and move half of the height, and you still get a center. Is that not true? Yes, when you divide this place into 2 and you divide this place into 2, this is serving as the center. So for plane figures like this, it is very easy to locate their centers. So here, for a rectangle, our x bar, which is the distance you move on the x direction to locate the center. So this, I'll move half of the base, which is half of the base. And for the y, the distance I'll move on the y will be half of the height. So it is also half of the height. Are we okay? So if the height is 50 cm and the base is 60 cm, to locate the center or the centroid of this rectangle, it is going to be x bar, y bar, and on the x, since it is 60, I'm going to move 30, and since this is 50, I'm going to move 25. And with this measurement, you're going to locate the center of the rectangle. Are you okay? Very simple. We will tackle many questions on this properly, and we would apply them. What about this is circle? How to locate the center of a circle? It's very easy. For circle, you can just know that this is the center. If only it is a plain figure where the dimensions are what? Accurate. Are you okay? Remember, for irregular shapes like what we saw, you cannot place the center anywhere. But for the regular ones, you can do your observation. So this is where the axes are. I'm going to locate the center based on the position of this axis. Where do I go? Now, I know that for a circle, from this point to that point is a diameter, d. And from this point to that point is also a diameter, what? D. So, on the x, to locate the center of a circle on the x, can I move half of the diameter, right? Half of the diameter will give me, d is diameter, will give me the center. And on the y2, if I, based on where the axis is, if I move half of the diameter again, I am going to get the center. Where half of the diameter is the radius, half of the diameter is the radius. Are you okay? So meaning, if I move the radius on the x, radius on the y, I am going to get the center of a circle. So if the radius or the diameter is, say, 10 centimeters, then the center of the circle, x bar, y bar, is going to be 5,5. Are you okay? Depending on the axis. My reference has been depending on the axis, because we will meet instances where the axis will be placed at a different point, and I'll show you very soon. So let's look at the last shape, which is a right angle triangle. A right angled triangle. How to locate the center? Look at this shape. Can you just place the center at any point by observation? No, you can't. You cannot place the center by observation at any point, say here, or say that. No, but it is proven from experiments that to locate the center of a right angle triangle, pay attention. For a right angle triangle, we have where the 90 is, and we have where the angles can be placed. If you are to move from where the 90 degrees is, and it is advisable that always you move from the 90 place. But if you also know the other dimensions, that's good. Are you okay? So always I'm going to start my movement from where the 90 is. To locate the center of a right angle triangle, starting from the 90 angle, you have to move on the x bar. So meaning I have to move a certain distance here, move a certain distance where they will meet. That will be my center. So from formulas, you are going to move 1/3 of the base, and on the y bar, you are going to move 1/3 of the height to get the center of a right angle triangle. 1/3 of the base. So let's say this is 1/3. You divide it into 3, and here too you move 1/3, and this place is going to be the center of the right angle triangle. This is a right angle triangle, not a triangle, a right angle triangle. So for a right angle triangle, moving from the 90 angle place, you move 1/3 on the x, the distance given 1/3, and 1/3 on the height too, you are going to get the center. What if I want to start from this place? Let's say the angle place. So this is 1/3 of the base, meaning it is left with what? 2/3, right? If this is 1/3, meaning the height is left with 2/3, 2 on 3. So if you are going to start from this place as the origin, then the x direction, you should move to test, that's 2 on 3 of the base. And if you are going to start from this place, that will be also y bar to test off the height, and you are going to locate it. I think the 1/3 is the best one to locate it, very easy, but once you also know this, it is okay. So these are the approaches to locate for simple shapes: the square, the rectangle, the circle, the right angle triangles that we know, because all this while we are going to combine these shapes for composite shapes, and you will be asked to determine the center. So once you know for the single shapes, it is easy to move. You see these ones, they are just observation, observation, observation. But for the right angle triangle, you have to know that it is 1/3 and this is 1/3. Are you okay? Let's look at this. Is semicircle. Yes. Look at the semicircle. You see two semicircles here. We are to locate the center from the first one and the second one. Do you see difference in position of the axis? Yes. Looking at the first one, the y-axis is in the center, and the second one, the y-axis is still at the beginning, the origin. Do you see that? Okay. So meaning you are going to find your center of this semicircle depending on the axis they've given you. You are not to bring it here. Don't say, no, I will set my own question and bring the axis here. No. Depending on the axis they've given you, where is the center going to be? So looking at here, by observation, you can see that here clearly the y is in the center line, or the center of the semicircle. It is dividing it already, right? So, but the x is not dividing it. Are we on the same page? Yes. So if the y is dividing it, then what distance should I move on the x-axis to locate the center of this semicircle again? There's no distance, because already if you move here as your x, you'll be distorting the center. You will not locate any center. If you move this place, no center. Already the x, you don't have to move any place to get the center. It has divided the x for you. So that's why we are saying the x bar is 0, depending on the axis. If the axis was here as your y, then you have to move a certain distance to locate your x. Are you okay? But here it is already there, so there's no movement to locate the x. So the x is 0. But since the y has positioned itself at the center, I have to position the x also at the y distance to find the center. So if I want to get the center of a semicircle, then to move on the y-axis, it is also a formula work, where y bar is giving us 4 multiplying the radius of the semicircle on 3 pi. Are we okay? So this formula will help you locate the center. So let's look at this place. For this, the y is here. It's positioned at the origin. Are we good? So to move on the x direction to locate the center line, we know that this is just half of a circle. So to move in the x direction, I can move half of the diameter or the radius. So x is either half of the diameter or the radius, and once I get the x here, I have to also move a certain distance on the y, which is for semicircles, your y is always 4r on 3 pi, and you locate this. So do you see that the formula is different from when the axes are here, and if the axes are changed? Here your x is 0, but here you are getting an r or d on 2 depending on the axis. So put it in mind, if the question is given, you pay attention to the axis, you solve more questions, don't worry. So what about a quarter circle? For a quarter circle, where the axes are at the origin, your x is the same formula giving us 4r on 3 pi, and this is bar, and your y bar is also giving us 4r on 3 pi, and you'll be able to locate the center. Are we okay? So with this as the introduction, you should be good, and you should also know more about the center, how to locate the center, where a single force can be replaced to represent the entire forces or entire weight of the plane figure. In our next episode, we are going to tackle composite shapes, or we are going to solve some examples for this single shapes. Because we just tackled the introduction, I'm going to give you some real questions with dimensions given so that we can find the center. Thank you for watching this episode. Watch out for the second episode.